Hello and welcome to this video on Game Boy background tiles. This video will show you the paint program that I use to design my tiles, and I'll provide a link for you to download it for yourself as it is free and open source. The paint program that I use is LibreSprite. So if you go to their site and then go to downloads, you'll see there's downloads available for all platforms. I recommend using the app image version for Linux. Now, what I wanted to talk about next was when you design your tiles. On screen here, what we have is the ASCII table of codes. The ASCII codes stand for the American Standard Code for Information Interchange. Wikipedia describes it as ASCII codes represent text in computers, telecommunications equipment and other devices. Because of technical limitations of computer systems at the time it was invented, ASCII has just 128 code points, of which only 95 are printable characters, which severely limited its scope. Modern computer systems have evolved to use Unicode, which has millions of code points, but the first 128 of these are the same as the ASCII set. When we design our tiles on the Game Boy, we have 256 tiles. Now, if we want to display any text on the screen, then we might want to allocate some of our tiles to match the ASCII codes as shown here. So the ASCII codes 32 to 126 are visible on modern computers. So if we wanted to have a faux character set, we would just need tiles 33 to 126 to possibly match these if we wanted both uppercase letters and lowercase letters. Another thing to bear in mind as well is on the Game Boy as well is tile 0 is the actual background on the whole screen. So if you were to alter tile 0, it would change the graphics for the whole of the display. And one command in C which prints strings of text out is printf. Now, if you send a string of text to printf, it will expect the letters to be in the same sort of place as these numbers here. So if you want to print stuff out, you might need to align these letters to these code tiles here. What I'll do now is I'll show you the tiles that I've used for this project. This is the faux character set of uppercase characters here. So this image is split into tiles here. So this is tile 0 here and this is tile 32 here. Notice tile 0 is empty and tile 32 is empty. Tile 32 is usually the character which is displayed when you press the space key on the screen. One thing to note here is how I've laid out these tiles. So what I leave here is I leave the top row for the colour palette. So this is colours 0 to 4 here. Sorry, 0 to 3. If you want to replicate these colours, then this is them here for you. So here's the first colour here. That's the second colour. That's the third, and this is the fourth. Notice that they go from light to dark. On the Game Boy Pocket, these would be shades of grey. On the normal Game Boy, they are shades of green. These colours here are similar to the colours that Emulicious uses for the Game Boy. So to draw these tiles yourself, I recommend just using a standard paint package. You can either use LibreSprite like I have here, or use whatever paint package you're happy with. But just know that you should keep these tiles into blocks of 8 by 8. Now, when it comes to drawing larger characters, in here I have some 16 by 16 pixel characters which are built up of 4 tiles. So this fish character here, there's 2 characters at the top of it and 2 characters at the bottom. It's always best to lay them out when you're drawing background tiles, going from left to right and then top to bottom. And then the numbers here align with what they are in the ASCII table. Same with these characters here. Obviously I've added some others at the end here. I'll provide this picture in the description to the video. What we'll do now is I'll show you how to create a new project from our previous project. So navigate to where you created the last project. For me it's this location here on this machine. Then copy and paste that. Now rename it to BG Back Tiles 1. Now double click in there. Right, what we don't need is the GB file, the object file and the bin file. Delete those. Now we need to rename this to BG Back Tiles 1. Now if you edit this in a text editor, and then just change where it says the title of it here. And then copy and replace that there. If there's any links here to folders as well, then it's worth looking at that and replacing it as well. Now we've done that, we can minimize that. Now we should be able to open it up in codeblocks as a new project. So if double click that, and then go into our make file as well and change the name here, BG Tiles 1, and then save that and close that make file. Now we won't need anything from in here, as this will be a multi-file project from now on. So we'll delete those, delete that. We'll leave these 2 here because we'll still need to turn the display on and show the background when we're ready to draw. So if you go on to File and then New, and then go on to File and then create a new header file, click All, go into the path and then call it main.h and save, and then finish. And now what we'll include in here is gb/gb.h, and then save that. Next we'll create another header file, and this time we'll call it utils.h, This will be the start of our utility library of useful functions. So include gb.h again, and we also want to include std bool as well. So we have the Boolean data type. Next we need to create some custom data types. We'll just use the one we were using before, which is the unsigned char as a U8. Next we will create a custom structure. This is our simple timer. What we have here is our timer value will be a number between 0 and 255, and then this will be saved as like a private variable, and then our countdown will take the value of timer, and then every time we call the update function of tick timer, it will then -1 from countdown timer, and then when it gets to 0, the boolean here will switch from false to true. So this allows us to create a number of different timers easily. This is just going to be a utility variable which we can use for various stuff. So if you use variables over and over again on these old consoles, it's best to create global variables and just share them around. Next we will copy in the prototype functions for our timer commands. The init function here will initialize the passed in tick timer here. So this star means pass the data type by reference, so that all the changes we make on the passed in data type, when the function returns, the effects will remain. Whereas if you passed a variable without a pointer, then you're passing it by value only, so the number it represents will be passed into the function. But then when the function ends, all the changes will be lost. Next we'll pass in some graphic commands here, some useful graphic utilities. This here is just a function to set tile data for us. This will copy our character data arrays into the VRAM of the Game Boy. This command here will do as it says, it will clear the screen, so it'll basically fill the screen with tile zeros. This command here will put one tile on the screen, and this command here will put a 2x2 grid of tiles on the screen for us. So this will draw a 16x16 pixel image, and this will draw an 8x8 pixel image for us. And then this is it for utils.h. Now we need to add the accompanying source file for it. So go to File, New File, Source Files, make sure it's C. Next, tick All to add it to release, then go into the file path and then call this utils.c. Finish that, and make sure you include utils.h. Now a quick thing that I do here is all the stuff you need in your source file, copy and paste it in here to make sure that they line up. Just make sure you go through and fill them in after you've copied them in. and don't forget, otherwise you'll get an error later on and then wonder why. Although GBDK will complain if you try and compile the program with an empty function. So as you can see here, this is the passed in data type here. We change the as time elapsed to false, set the countdown and the timer value to the passed in delay value there. And then in the update function, all we do here is check to make sure the timer hasn't elapsed. If it has, then we subtract 1 from the countdown timer. If the countdown timer equals 255, then we'll set the has timer elapsed to true. Basically, as an unsigned char is a number between 0 and 255, when you subtract 1 from it each time, when it gets to 0, the value will wrap back around to 255. So we know that at that point it's elapsed. And then we return the fact that the timer has elapsed. And then in the reset method, all we do is reset the countdown timer and to the time interval, and then put the timer back to false. So you'll see here that set tile data literally is just a wrapper function around the GBDK function called set background 2 bits per pixel data. When we come to other consoles, most of these commands I will use again on that console. The only thing that changes will be the different command in here, which will be specific to the console you're coding on. So this command here fills the fills a background rectangle area. So it expects the left top and then width and height, and then the number at the end here is the tile number to fill that rectangle with. So this command here as well just wraps over the GBDK tile, set tile command. If you press F2 whilst you're in codeblocks, then it hides and shows the build message and build log. Sometimes when you copy and paste stuff in, it doesn't show you the whole lines of text that you put in, so you may need to close that to be able to get at the bottom line here. Now, the way that I've done this, so you'll see here that there's an unsigned char pointer called ptile. In this function, first off, we get the background address of the screen memory at the tile location we want to print a tile to. Then, once we've got that, we can now use this command here in GBDK, which is a fast way of putting a tile into VRAM. So this command here takes a U8 pointer, and then you just provide it with the tile ID, which in this case is called tile start. Then what happens, because it's a 2x2 image, a 16x16 pixel tile, you then need to update the tile number. Then you need to increment the pointer address. Then you draw the top right side of the image. Next, increment the tile again. Then because the tile map that you see on the Game Boy, as I described in my last video, is actually 32 by 32 tiles, although you can only see 20 by 18 of them on the screen at any one time. To get to the next line down, we need to add 31. It will then loop back round to the bottom left tile underneath the first one. It will become apparent when you see it all in the finished product here. So that's it from the utils library here. So next we need to create another header file. This one is called graphicdefines.h. Now we need to include utils into this one. Now this header file is usually where I include all of the graphical shortcut commands that I usually create for games. Rather than having to remember the exact tile numbers where a shape is located or anything like that, I usually come up with like a shortcut way of doing things. So I'll copy and paste a load of stuff in here, and then I'll explain it as I go. So pretty much I use defines for most of these things. So this allows you to fully automate the process of building stuff. So I usually come up with graphics tile start and graphics tile count for all of the like graphic tiles that I decide to include by parameterizing them like this. So this here is the start tile, which will be 0, and then there's only 45 graphic tiles in that set, so there's only 45 here. If I then decided later on that I wanted to have more in, then I can just change these numbers here and then the program stays as it is. Now these here, these are just references to where individual graphics lives in the tile set. I'll bring up the image again so you can see. Now tile 1, which is the floor, tile 2 is a wall, tile 3 is the smiley face, tile 4 is the invader, and tile 5 is the heart there. Now these next ones get into 16 by 16 tiles. So tile 6 is where the fish character starts, and you'll see there's the top left, top right, bottom left and bottom right. That's frame 1. There's another animation frame here for the fish. So if I scroll across here, you'll see there's the next frame here, so that's top left, top right, bottom left and bottom right. So what I can do here is each graphic has 4 tiles to it, so I know to get to the next frame I just have to add 4 tiles, and then after the fish there is a back character, and then after the back character there is a star character, and then I have 2 more characters, and then the final tile is a 16 by 16 tile. So by giving them all references like this, I can call them in code, and then should I decide to change the location in the tile set where they are, all I have to do is change this number here, and then everywhere else in the program where it refers to this name to draw it won't need to change. I find that works well. So I do that on every other console as well. I try and kind of code things in such a way now that it's easy to copy and paste it onto other consoles. So now we've got this one here. So this command here, what I also include in the graphic defines is where I declare the array structures to hold our tiles. So what we need to do now is add the source file where the tile data will live. Let's go into File, Source File, C, click All. Then this one is just graphic tiles.c, and then finish, save that, and then include graphic defines. Now I'll copy and paste in the data for those tiles that you just saw. I will add all this data in the description to the video for you, so you can so you won't want to type in all these numbers. So this is formatted here so that there's 16 bytes on each line. Each line basically represents one tile. So all what's left to do now is get all this stuff to work. So now we've got all this stuff, let's make something interesting with it. Oh yeah, we're going to need to make sure we include in here now our utilities library and our graphical defines, so that the main file can now pick up all these data types. So for our animation we need a timer, then we need to record what frame our animation will be on, and this is how long it will take. This method here is going to be where we update our tiles. So in here now, back into our main thing here, we want to set our tile data. So first we pass in the graphic tile start, then we pass in how many we need, and then we pass in our pointer to our array. Next we want to clear the screen. Now we can set up our timer now. So we'll pass our timer to the function with our animation delay there. So that's our animation timer set up now. Now I will just draw some of those tiles that I talked about previously so that you can see them here. So these here, this will go down the screen 3 tiles at a time. This is just going to be a vertical variable here. This one here is going to go from 0 to 20, so that's going to go across horizontally on the screen. And this will basically, tile 8 here will be 1, which is the same as our floor tile. So we'll draw a row of floor tiles first, then we'll update tile 8 by 1, so it then points to the next tile. Then we'll go down the screen by 3. You'll see in the results anyway. This is just an example for you to get a feel of what we can do here. Now what this does is, so we're in the main loop of the program here. So every time this loop runs, our timer will be subtracted by 1. If the timer gets past 0, then our frame will increment by 1. If the frame equals 2, then it resets back to 0. Then we reset our animation timer. Then we call draw blocks 16 again. What you'll see here is we draw a 16 by 16 tile here. We use block start, which takes the animation frame times 4. The reason why it's times 4 is because there's 4 tiles which make up each of the starting locations of the 16 by 16 pixel images. So this is everything here for this demo. Now if you build it, oh, I see what I've done here. I didn't include the main header file. And I think I've given it the wrong name. There we go. So now if we go back to the folder where, now if we navigate back to our folder here, we should see the BG Tiles program. Now if we navigate to Emulicious here, if all went well, you should see all of the 16 by 16 pixel tiles animating. Now you can double check to see what's going on here. If you go into Tools, then Tile Viewer, if you're seeing the colours dancing around, it's because you need to change the palette to BGP0. Now what you'll see, this window here is showing you the tiles in the VRAM on the Game Boy. So what you want to look at here is this number here is the tile index, so 0, 1, 2, 3, 4. And you'll see here, these are the various places in the Game Boy's memory where tiles could live. GBDK has set the background tiles to live here. Now if you go into Tools again and go into the Tile Map Viewer, the tile map is the screen memory, if you like. As you'll see here, there's 20 across by 18 down here, and the blue line indicates where the scroll registers have got the window as being in the memory. So when we come to scrolling later on, you'll be able to see this window actually shifting here. What it also means is you can draw a larger area here and only have a smaller part of it actually viewable. Right, that's it for this video. We will come back to background to tiles again next time and do something a bit more interesting with them. That's it for now.